Hey, welcome to day 11, and we're going to do some more live coding, and hope it goes well. I'm actually doing this one right after it came out, so um, one of the first. Hex Ed, crossing the bridge, you've barely reached the other side of the stream when a program comes up to you clearly in distress. It's my child process, she says. He's gotten lost in an infinite grid. Fortunately for her, you have plenty of experience with infinite grids. Unfortunately for you, it's a hex grid. The hexes are aligned such that adjacent hexes can be found in the north, northeast, southeast, south, southwest, and northwest. You have the path the child process took. Starting where he started, you need to determine the fewest number of steps required to reach him. A step means to move from the hex you're in to any adjacent hex. For instance, northeast, northeast, northeast is 3 steps away. Northeast, northeast, southwest, southwest is 0 steps away. Northeast, northeast, south, south is 2 steps away. And southeast, southwest, southeast, southwest is 3 steps away. And southeast, southwest, southeast, southwest. Okay. So we need a couple things. One is first we need a coordinate system. So let's see what hex grid says about this. Hexagonal tiling. So how do we want to represent this? And this Wikipedia article might not be helpful, so we will have to puzzle through this ourselves. Okay. So, or we could try and cheat. And how could we try and cheat? We could try and cheat by saying that if I do a southwest and a southeast, that combines to be a south. If I do a northeast and a south, that combines to do a southeast. If I do any two of these, yeah, I don't know if that. Let's look at my puzzle input first. Could be we can just kind of cheat. No, that's a lot of moving. Well, let's play around with this a bit. Does it matter in what order we go in? If I go south and then southeast, or if I go southeast and then south, it shouldn't matter. So one thing I could do is let's just save this. And call it day 11 hex. Actually, this is day 11 input.text. And here, for the first time, I'm not entirely sure how to solve this problem. So you might see a little bit of interesting fumbling. A lot more interesting fumbling, actually. Day 11 hex.py. And let's get this in my docstring. So the first thing I want to do is basically say, with open day 11 input.text as f, and I'll put it in my name equals main block. So let's say, path equals f.read, and let me just split on commas, and I think that is going to give me a bunch of stuff. And so now I will import counter from collections, import counter, and let's just print the counter of the path, and that will just show me how many of each move there are. And will that help us? I'm not sure. I should probably put a strip in there, f.read .strip.split. So let's try this again. And so, for every southwest and northeast, they cancel out. For every northwest and southeast, they cancel out. For every north and south, they cancel out. So let me just play around with that. C equals that. So C north minus equals 1294. String indices must be. Okay, because I did not assign it to anything. So let's just when we do this, counts equals counter.path. That's good. So let's say counts s equals 0, counts n minus equals whatever counts s was, 1294, counts northeast and southwest are the opposite, so that equals 0, counts southwest minus equals 1352, counts northwest is 1495, which is bigger than southeast, so let's do minus equal 1059, and then counts northeast equals 0, so let's try counts again. So now what we have are a bunch of north, a bunch of southeast, and a bunch of southwest. And now I can combine southeast and south. Every southeast and southwest is a south, right? So if I say counts southeast minus equals 325, counts southwest minus equals 325, and counts south plus equals 325. Then I have counts again, and now I can take away, counts n equals 0, counts s minus equals 52. Unless it counts again. Now I have a bunch of northwest, southeast, and south, and I can cancel off a bunch of those and say counts northwest minus equals 436, counts southeast minus equals 436. Let's look at counts again, and now we've basically said that I have a bunch of south and southeast. So what is the idea here? The idea is that basically wherever I get to, so like let's say I'm somewhere over here, I should be able to get there by going only in two adjacent directions. And similarly, elsewhere, I can get there by going only in two adjacent directions. And so the question is, how do I do that in kind of an interesting programmatic way? So let's think about that. I mean, I could do it by hand like that, but that feels a little bit hacky and bad. So, eliminate opposites count, which is going to be a dict from string to int, and it's going to return a bool. So, if counts n bigger than 0 and counts s bigger than 0, eliminate. Let me do this. Eliminated equals false. ns equals min of counts n counts s. And I'll do this. northeast southwest equals min of counts northeast counts southwest, and northwest southeast equals min counts northwest counts southeast. So I'm still not entirely clear that if ns is bigger than 0, or northeast southwest is bigger than 0, or northwest southeast is bigger than 0, counts n minus equals north south, counts south minus equals north south, counts northeast minus equals northeast southwest, counts southwest minus equals northeast southwest, counts northwest minus equals northwest. So I'm just eliminating basically opposite moves. If I go, at some point I go northwest and at some other point I go southeast, I can, get rid of those. And then count southeast minus equals northwest southeast, and then I will return true, meaning that I eliminated something. Otherwise, I'll return false. And then let's I'll call my other one condense, which is dictionary from string to end, and that will also return a bool. And so what will condense do? It basically, the idea is that north plus southeast equals northeast, etc. So I'm just going to eliminate pairs this way. Let me think about how I want to write this. If counts n bigger than 0 and counts northeast or southeast bigger than 0, then actually let me I should use a slightly different abstraction here and just say let's just say -1 string -2 string plus string, and so that way so let's say eliminate equals min of counts -1 counts -2 if eliminate is bigger than 0, counts -1 minus equals eliminate, counts -2 minus equals eliminate, counts plus equals eliminate. Okay, and then I'll return true. Otherwise, I'll just return false. And I'll call this underscore condense so that I can call it def condense counts dict stir comma int. Again, this will go to a bool, and I'll just try and condensed equals false. And so, for M1, M2, P, N, so here's where I'll just start saying north and southeast go to northeast, and let's just go around the circle. So if I go northeast and south, those combine to do southeast. And if I do, and I'm just northeast. If I do southeast and southwest, they combine to be south. And if I do south and northwest, they combine to be southwest. And if I do southwest and north, they combine to be northwest. And if I do northwest and northeast, they combine to be north. So, you know, for all these guys, I want to try and eliminate. So, condensed equals condensed, or this is a mess of code. Condense counts M1, M2P, and now while true, if not, and I'll just keep trying to do both of those. If not, eliminate opposites counts, and not condense counts, break, and let's print the counts. So let me do all of this here. Print well, you know, let's just run this and see what happens. So here I got 273 south and 298 southeast, right? So what happens if I run this thing? I got 273 southwest and 488 northwest. So northwest and southwest. Let's print all this stuff. Print, eliminate opposites and counts. And here, let's print -1, -2 plus counts. And now let's run it again and see what it's doing. So, you know, this was our original. So let's print the counts originally too. Okay, so I start with this. I eliminate opposites. After I eliminate opposites, I get 436, which is northwest versus southeast. So that seems right. I get 325 southwest and 52. So 436, 325, 52. Is that what I got? Before when I did all this. 436, 325, 52. And did I forget to subtract off south? Okay, so I screwed this one up. Or no, I didn't actually. So let's look. Southwest and anyway, I got something different, but that's okay. So I eliminate opposites, and this is what I get. And so now I want to do, once I do that, I have north, northwest, and southwest. And so I should get something good when I pair up north and southwest and eliminate northwest, right? And or eliminate those two. So I subtracted off 52 here, I subtracted off 52 here, and it gets me down to those two directions. And now if I want to go that many times, I'm probably in trouble. So I think I believe that. Let me do this again by hand and see if I get the right results, because I think I screwed that up. C equals this. So C, we have the north and south, so Cn minus equals 1294. Cs minus equals 1294. And then we're going to do southeast and northwest, so C northwest minus equals 1059. C southeast minus equals 1059. And then we want to do a northeast and southwest, so C northeast minus equals 1352, and C southwest minus equals 1352. And so now I have this 436 and 325. And again, I can basically do Cn minus equals 52, C southwest minus equals 52, and C northwest plus equals 52. So I get 488 and 273. And is that what I got before? 488, 273. Yes. So let's just make sure that it does the right thing on this as well. Let me just do this. Path equals southeast, southwest, southeast, southwest, southwest, southeast, southwest, southeast, southwest, southwest. And so now if I run it, I get 2 and 1, which is 3 steps away, south, south, southwest, and that's what I've got. And let's just try this as well, northeast, northeast, south, south. These are not great tests, but I think I'm doing the right thing. Northeast, northeast, south, south. And now if I run it, I just get 2 southeast, so that seems right. So let's try this. The worst we can do is get it wrong, right? So 488 plus 273 we said is 761. So let's try 761. Hey, that's the right answer. Good. So whatever we did, it worked. Cool. So let's return part 2. How many steps away is the furthest he ever got from his starting position? Okay, so now we actually need to write a function for this, basically, which I avoided. But so let's say distance is some counts, which is a dict from string to int, and that will return an int. And what am I going to do? I don't want to destroy the counts, so I'm going to say counts equals kv for kv in counts.items. So I'll make a copy, that way I can destroy it. And then I don't want to destroy it because I'm going to be like doing it step by step. I'm going to put this loop in here, and now I want to return sum of counts.values. So print distance of counts, and let's just print the counts again to make sure that we haven't actually messed with it, right? So it's still the same as it was originally, and we get the 761. So that is good. And let's get rid of that these print statements because they're too much. Okay. So, here's what I'm going to do now. I'm not going to use a counter. What I'm going to do is, I'm just going to say counts is going to be dict. Actually, I will use a counter. Let's make life easier. Equals a counter. So for move in path, count move plus equals 1. Dist equals distance counts. Print move dist, and let's do max distance equals do float negative infinity again. If dist is bigger than max dist equals dist, and I'll just do this. And now let's run it again. Key error n. And so why did that not work? Okay, so let's make, instead of making this a counter, let's make this a default dict, and it will be a default dict of int, so that way when I try and get something that's not in it, I'll just get a 0, which will work. And because how do I copy a default dict? That's what I want to Python make a copy of a default dict. From copy import copy. So let's try that in our REPL. From copy import copy x equals default dict int x10 equals 5 x y equals copy x y x4 equals 3 x has 4 y doesn't. Perfect. So that's what I want to do, and that's actually cleaner. From copy import copy and counts equals copy counts. Okay, so that should be fine, and now let's try running it again. And so that got 761, which is what we wanted, and the furthest we ever got was 1542, it says, and that was when we were so let's think about this for a bit. We're going north, we're going north, we're going north. And we keep going north, and we keep going north, but we're not changing how far we are. And that must be because every north gets netted out with some other direction into a third direction. So that seems fine. And then we get there, and then we turn around and start going back, and we turn around and start going back. So we must be off to the west. And then so this is saying 1542. I think I have no reason to disbelieve it. First he ever got, so 1542. That's right answer 2. And one of the ways this advent of code works is when you're one of the first 1,000 people to solve the problem, like right after it comes out, you end up on the leaderboard, and we got rank 564, which means, actually maybe it's only the first 100, but yeah, well, still, that's still pretty good. So yeah, we solved that. I almost got distracted by trying to write out those coordinates because part of me really wanted to say what coordinates do we end up at and net it out that way. I can't think of a great way to do kind of canonical hex coordinates. So I think what we did is probably a better solution. But you could see I kind of got flustered a little bit because I wasn't sure if what I was doing was going to work. So that's more flustered than you usually see me get during these things. But you know, we got it done. So thanks for watching, and you know, find me on Twitter at Grus, and I will see you next time.